This is my circuit for the Lab 9 traffic light simulation. Um, I will go more into depth after I describe the states I put or have placed for the circuit. Um, Here is my state diagram. Here we have 6 states: S0, S1, S2, S3, S4, S5. Let's start with S0. This is a default state, which means that when reset is inputted with a 1. Um, this finite state machine will return to S naught. And in this, so looking back at the circuit, um, when this becomes is inputting a 1, then the lights on academic will be green and the light on bravado will be red, as it is right now. And also, the turn signals are separate from the actual signals. So while the lights on A and B are green and red respectively, both turn signals on A and B are turned off. And this will continue to happen so long as there are cars being sensed on TA E star and TA West L, which I will explain further. So here is the diagram of the intersection. For the first state, we are testing whether there are cars on the like cars being sensed on TA West L and TA East R. As long as there's cars being sensed, cars will be able to go on straight path on academic, but will not be able to turn. When these sensors do not sense the cars anymore, outputting a 0, then we move on to the transition state S1, where the light on A is yellow and the light on B is red. A as in academic, B as in bravado. The turn signals are still turned off. And just to mention, the only times the states will change is when the clock ticks. By the clock, I mean this clock over here. So every time it inputs a 1, it'll check the external. It'll check all the sensors, and if the conditions fulfill for the state transition, it will transition during the clock tick, but it won't do anything outside the clock tick. So once the clock ticks again, we move on to state 2, where we have both red lights on A and B. However, the turn signal on A is on, meaning turning is allowed from academic to bravado. And here we're testing. We're checking the sensors on TB North U and TB South D, seeing if any cars are passing through the intersection onto that side of the street. Once the sensors TB North U and TB South D don't sense any more cars, meaning that the output's 0, we move on to S3, which is the next state. Here we have the light on A red and the light on B green, while both turn signals are off. And this state will continue to repeat itself so long as there is cars sensed on TB North D and TB South U. TB North D, TB South U. So as long as there's cars passing through the sensor into the other side of bravado, cars will continue to be able to pass through bravado, but cars on academic will just be stopped because there's red light on academic. Now, when there's no more cars being sensed on North D and South U, right? If there's no more cars being sensed here, then we move on to the next transition state, which is S4, where LA is R and the light on B is yellow. Of course, after a tick, we move straight to S5, where both lights on A and B are red, but on B, turning is possible, signifying by LBT is on. And this state will continue as long as TA East L and TA West R output a 1. So as long as there's cars passing from bravado onto academic to the east left side of the intersection, or the west right side. Once that stops, we revert back to the very first state. S naught, and this continues for every condition that it has. Let's move on to the simulation and check and see if it works. So, right off the bat, when I click, oops, hold on. Oh, sorry. Yeah, right off the bat, as you can see, everything, every time the clock ticks, actually, let me simulate this. Every time the clock ticks, the state, oops, hold on. Every time the clock ticks, the state changes, right? And this is because we haven't inputted anything from the sensors on the intersection. So let's turn this simulation off for a little bit, and let's also check to see if the reset works. So here we are, we're on a different state. If you add a 1, it reverts back to the S naught state, right? Now, so long as there are cars on east and west, the what do you call it? The lights on academic should be green, and the lights on Bravado should be red, which is the case, right? Right when we take off the sensors, as in like right as soon as there's no more cars being sensed on these two sensors, the state transitions to yellow, and then transitions to turning, right? As you can see, the street light on academic is red, and the street light on Bravado is red, but turning is being allowed on academic. Now, looking at our state diagram, as long as TB South D and TB North U are outputting a 1, the lights should stay where they are right now, which they do. It's sensing that cars are being are turning onto Bravado. Likewise, once we sense no more cars, we move straight onto state 3, where now straight track was being allowed on Bravado. In this state, we're sensing whether the cars are. We're using the sensors TB North down, TB South up, and as these are turned on, the state stays the same. As in, like, the state stays in S3, just as how our state diagram suggests. Now, once there's no more cars being sensed on these two sensors, there's what do you call it? It goes to the next state, which is the transition state S4, and then finally onto turning allowed from Bravado onto academic. Here we're sensing TA East L and TA West R. So as long as there are cars going onto these sensors, we should be staying in the same. Yes. So left turn on Bravado to academic is going to be allowed so long as these two sensors are active. When they're no longer active, we move back to, hold on. We move back to the very first state, and as long as this keeps on ticking, we'll keep on cycling the states without any inputs. In order to figure this out, I created a state transition table with all the the outputs and the inputs and outputs, and made and made a sum of products and products of sums to make an equation for to create all the to figure out where, like, to figure out how to create the circuit. Anyways, thank you for listening to my description of how I made this Lab 9 traffic simulator.